I'm Vivek from K4 Metrics, and in this video, I will show you how you can calculate forces and moments across the span of your geometry. In this example, I'm taking the Onera M6 wing example, which is available in the Tecplot installation directory. So, if I have to do this manually, I have to create 1D slices across the y direction that I'm interested in, like this, and I have to add slices, a lot of slices in the direction y, and then I have to integrate forces and moments on each slice, and then I have to plot the graph. So doing this manually is a tedious process, and Tecplot has written a Python script to automate this process. So this is the Python script, forces, moments versus span, and this can be downloaded from the GitHub website of Tecplot. So I will leave the link in the description for you. So this calculates forces and moments first based on three different methods using the surface zones and the variables. Um, so the first method is just by using the variable pressure. The second method by using the variables pressure and shear. The third method using the variables pressure and velocity. So this you can define which method you want the script to use in line 241. So you can see currently it is selected for the mode pressure. So if you want the other ones, you can remove the hashtag and make the one that is current as a comment. So once it calculates forces and moments, then it will start creating the slices based on the number of points, direction, and the positions that you have defined. So again, I'll scroll down to show you where you have to specify this. So this is from line 234 to 237. So you can see that for my example, so the script will be creating 200 1D slice in the direction y from 0.05 to 1.15. And once it is done creating the slices, then it will start integrating using the forces and moments. And once the integration is completed, then it will create an XY plot, that is forces versus span. And this script is pointing towards the Onera M6 example. So you can see line 256, it is looking at the Tecplot examples directory, and 257 says the Onera M6.plt file. So you have to modify this bit such that it points to your data file that is there on your machine. So once you're done with the modifications and then you're ready to uh, run, you can just hit run here. So I'm using Thorny, which is a Python IDE. So you can run this in your terminal or in your command prompt as well. And before running the script, make sure that in Tecplot under the scripting menu in PyTecplot connections, make sure that this accept connections is turned on. So close this. I'll go back to Thorny and I'll click on run script. So you can see that the script has started to run. While this is crunching, let me just show the Tecplot installation directory. So a Tecplot uses its Python API called PyTecplot for running the scripts. And this is the PyTecplot folder in the Tecplot installation directory. And this is the requirements.txt file available there, which contains Python libraries that is required for you to run the scripts. So make sure that you have these libraries installed on your workstations. So let me just go back to Tecplot and wait for the script to get completed. Okay, the script has completed. So let me just go back to Thorny and can say the script is ended. So this is the plot, XY plot that the script has created. So this, you can see fx, fy and fz here in the y-axis, and the span in the y direction in the x-axis here. You can turn on symbols. So you can see these are the 200 slices. Each point represents the 1D slice across the span of the wing. So I can show you the slices as well. So if I turn on slices here and change this to the surface zones. So you can see this is the 200 slices that it has added across the span, and accordingly the forces and moments plot in the second frame. So this is how you can use this Python script to calculate forces and moments across a span and then plot it as an XY plot. So this completes this video. If you have any questions, please feel free to reach out to us or drop a comment down.